In this example, suppose that the endpoints of the diameter of a circle are at the ordered pairs -2, 3 and 8, -5. Now with just this information, we want to go ahead and find the equation of the circle. So let's pause for a cause real quick and just think about what we have on our graph. So here's the graph of our beautiful circle with our two endpoints. And we know that these endpoints are the endpoints of the diameter, or the full length of our circle. So in order to find the equation of a circle, we need to identify the center point HK as well as the radial length R. So looking at our graph, we can see the center point will probably be somewhere around here, which in fact is the midpoint of the line segment, aka the diameter. So to find the center point here for our circle, we just need the midpoint formula. So recall that our midpoint formula, x and y are the average of their respective variables. So we can label our given points. We'll let -2, 3 be x sub 1, y sub 1, and we'll let 8, -5 be x sub 2, y sub 2. So plugging these into our components, for x, we have -2 plus 8 divided by 2, or 6 divided by 2, which leaves us with 3. And the same idea for our y component. We have +3 plus a -5, all divided by 2. So notice here we have a positive times a negative value, which we of course know becomes negative. So 3 minus 5 is going to leave us with a -2 by 2, or -1. So we could say that the midpoint, or the center point of our circle, is at the ordered pair HK, where H, our x component, is 3, and K, our y component, is -1. Now that we have our center point, the next thing that we need to do to get the equation of our circle is to find our radial length R. So again, let's take a step back to our graph here and keep in mind that the radial length is half of the diameter. So there's several ways in which we could go about doing this, but since we have our center point and an endpoint of the diameter, to find our radial length R, we can simply use the distance formula. So for our distance formula here, we're using the point HK and 8, -5. Keep in mind that you could also use the center point and the other endpoint of the diameter, and you'll get the same answer as long as your algebra is accurate and consistent. So again, using HK and the ordered pair 8, -5, we have 3 minus 8 squared plus -1 minus a -5 squared. So simplifying within our parentheses, we have negative times a negative, which is positive. And this is equal to the square root of 3 minus 8, which gives us -5 squared, plus -1 plus +5, which is equal to 4 squared. So we have the square root of 25 plus 16, which leaves us with the square root of 41. So our radial length, the radial length of this circle, half the length of our circle, is defined as the square root of 41 units. So now we have everything that we need to define the equation of our circle. Again, we'll keep in mind that we defined this equation at the beginning, and we're taking what we found and plugging it in for the center point, as well as for the radial length. So we can rewrite this as x minus 3 squared plus y minus a -1 squared is equal to the square root of 41 squared. And there's nothing really wrong with this answer except it's not aesthetically pleasing. We want to simplify this a little bit further. And we can do this, noticing we have a negative times a negative, that will become positive. And here on the right-hand side of our equation, the square root and the square will cancel each other out, leaving us with x minus 3 squared plus y plus 1 squared is equal to 41. So there you have it. This is our beautiful final answer for the equation of the circle, given just the endpoints of our diameter.